All right, and thanks for joining us today. My name's Zach with ATS. I'm sure I see a number of the names in the chat. I'm sure you recognize the face and the name at this point as we do our rotating series on various products and application groups for ATS University session. As with all of our sessions, this is recorded so that you can access it on our website, atspec.com, where you can find the ATS University section in our Learning Hub and access all of our sizing guides, as well as previous webinars that may have a topic of your interest. As with this, our Franke Infection Prevention and Control presentation, presented today by Angela Bird, and any of our other topics, if you wish to set up a session specific for your firm, just email me, zach@atspec.com. We also have a booking page on our site that you can send a request to. We'll be happy to set it up or have one of our team set it up. We've got Phil down in California for our US team, our US East, our Quebec team with Melanie, and of course, Natalia covering Western Canada, and myself and Mo in Ontario. So a wide variety of people to lend a hand and help set up a presentation if you ever wish. As with all of our recorded webinar sessions, everyone's muted upon entry, but I'll be keeping an eye on the chat and the QA field to bring up any questions along the way to Angela. Angela, I know you're giving me the brief extended history of your time at Franke as we got started. So you've got an ample amount of experience to lend a hand on the discussion today. Thanks for coming in, presenting on engineered infection prevention. I know this is a hot topic.
Yeah, thank you so much, Zach. Thanks everyone for participating in the CEU today. We appreciate your time. This will take about 45 minutes. If there are any questions or additional information that you're asking about that I don't know, I mean, I'll do my best to answer what I know, but I'm filling in for our product development engineer who is away today. He's the one that knows this subject topic inside and out, front and back. If there's something that technical that I don't know, we can make note of them and answer them by email afterwards. But there is an FAQ at the end, so.
We'll have all the contacts or follow-up. So if any questions come up that we can't handle today, we'll be sure to reach out. Awesome. And I guess one other piece of housekeeping, if you're in the US and you need to register, we can send you the registration number for the AIA CEU afterwards. Just shoot us a note. And if you are in Canada and you just need your certificate of attendance, then we'll be having those sent out on Friday as per our typical process.
Great. So here are the learning objectives for today's CEU. So first, we'll discuss the problems faced by North American healthcare facilities related to hospital-acquired infections, or HAIs. You'll hear that a lot. Next, we'll review technologies that have shown to have a dramatic impact on reducing hospital-acquired infections. And those are UV disinfection, copper coating on high-touch surfaces, and ozone disinfection and hand hygiene sinks. And by the end of this presentation, you'll have a deeper understanding of the benefits of ozonated water related to hand hygiene. And lastly, we'll discuss how ozonated water technologies benefit hospital cleanliness and improve patient outcomes. So first, we'll cover the basics. What is a healthcare acquired infection? We call them HAIs. HAI is short for healthcare acquired infection or hospital acquired infection. We'll use those interchangeably. An HAI, put simply, is an infection that you get from a hospital. There's 4 criteria to labeling an HAI, and it can meet one or all of these criteria. 1, it's acquired up to 48 hours after admission to a hospital. It's acquired 3 days after discharge from a hospital. It's acquired up to 30 days after an operation, and or it's acquired in a hospital when admitted for something other than the issue or problem that you went in with. So as I go through this, I'm going to be talking about stats and information that was found and researched before the pandemic. So all of these facts and figures are pre-COVID. Even though COVID has likely impacted these figures, the team felt that it was important to not just kind of take a guess. The COVID has impacted these numbers, but we felt that this information was good to present on its own. HAIs are among the leading causes of death in North America. When we look at Canada and US per capita, HAIs are estimated to be the third leading cause of death. And these stats are pretty alarming. Every 45 seconds, a hospital patient is infected with an HAI, and every 8 minutes, a patient dies from an HAI. So on any given day, 1 in 31 hospital patients have at least one healthcare acquired infection, and 1 in 10 of hospital infected patients will actually die from their HAI. There's a huge economic impact as well. HAIs are expensive. The estimated average direct cost for HAI treatment is about $30,000 per case. And according to a University Health Network study, C. difficile cases cost over $38,000 to treat. The direct treatment cost for hospital-acquired infections is estimated at around $45 billion annually. And I mean, that's pre-COVID information, like I said. I'm sure COVID's made it worse. The total cost to the healthcare systems, to families, to the economy, and to individuals is even higher. HAIs have a domino effect on the whole healthcare system. Infected patients stay in hospitals much longer before being discharged, and approximately 10% of acute care beds in urban hospitals are occupied by patients who have had an increased length of stay due to their HAI. And so when patients are in the hospital longer, they take up valuable bed spaces. Patients end up being treated in hallways and lounges or squeezed into rooms designed for fewer patients. I mean, we've seen the overcrowding. ER wait times are also increased because the ER is stacked with patients waiting for a bed to free up. So the 3 most common forms of HAIs are C. diff, MRSA, and COTI. Clostridium difficile is one of the most frequent infections to occur in hospitals. C. diff exists in a vegetative state inside the human body, and when it's outside the body, it can exist as a spore, which can become airborne and spread to surfaces. Alcohol-based sanitizers cannot kill C. diff spores. MRSA is a form of staph infection that is resistant to many of the common antibiotics used to treat staph infections. So due to their resistance, they can easily spread throughout the hospital, causing alarming outbreaks. And catheter-associated urinary tract infections can occur when patients are catheterized for a longer period of time, or if there's improper maintenance or procedures used to change or put in or remove their catheters. So containing the spread of HAIs is really important. Next, we'll look at techniques that hospitals and healthcare facilities use to help prevent the spread. So this presentation was initially created before the COVID-19 pandemic hit. Hospitals have likely improved their room cleaning protocols since the start of the pandemic. So when it comes to cleaning, patient rooms are first decluttered and then cleaned and disinfected to be set up for the next patient. The process is traditionally done with cloths and harsh chemicals at the very minimum. So a manual daily cleaning takes about 15 minutes to do. Surfaces are spot cleaned since patients are still usually occupying that room. A room turnover or terminal clean is performed after a patient has left the hospital prior to a new patient coming in. A room turnover clean takes about 30 minutes. And an isolation clean is the deep cleaning performed after a patient who's been in isolation or who's had an infection has left that room. That's an even longer process. It takes up to about 45 minutes. At best, fewer than 50% of the surfaces are properly disinfected using this traditional cleaning method, no matter if it's a daily, a turnover, or a post-isolation clean. Proper cleaning practices are important to help control the spread of infection in hospitals. And next, we'll be exploring the technologies that can help prevent healthcare-acquired infections that kind of go above and beyond just that straight chemical and cloth cleaning. These are emerging technologies, not because they're new, but because their use in the healthcare setting is becoming more and more prevalent. So, oh, that's a blurry photo. First, we'll review UV disinfection. So the use of UV for disinfection isn't new. Its antimicrobial properties were discovered about 200 years ago. UV light has been used to treat air, water, and surfaces since the late 1800s. This is a fun throwback. This is Finson's phototherapy apparatus being used to treat skin ailments in the late 1800s. Niels Tyberg Finson won a Nobel Prize in Medicine in 1903 for studying the effect of ultraviolet light to treat lupus vulgaris on the skin, which was caused by tuberculosis. So fast forward to modern times, studies have shown that UV disinfection has a dramatic impact in reducing healthcare-acquired infections. UV light will disinfect all surfaces, and it's extremely effective when used in conjunction with traditional cleaning. Rooms disinfected with UV have shown reductions of HAIs by over half. There's a huge burden on environmental services and cleaning staff during outbreaks. A few slides ago, we noted that the average time cleaning for a terminal clean is 3 times the length of a daily clean. So this graph here, I know it's kind of small to read. This graph shows the overtime hours at a hospital for terminal cleans. The data represents the number of hours that one hospital invested in cleaning each month. So the 2 spikes on the graph, I don't know if you can see my mouse, the 2 spikes on the graph here noted the increased terminal cleaning hours during a norovirus outbreak. So here, after the UVC disinfection technology was added, the number of cleaning hours dropped because the light not only, the light will disinfect everywhere it touches, not just where the chemicals and the rag are applied. So with fewer HAIs, there are fewer terminal cleans required. And from a hospital administration view, the potential payback for such a system is evident. So this is a graphic representing some results of a study performed on C. diff and how difficult it is to remove from hospital rooms with traditional cleaning methods, meaning just a cloth and some chemicals. So before manual cleaning, patient rooms were tested for the presence of C. diff spores. As you can see, 7 of 21 rooms tested positive. So after a traditional manual cleaning was performed, 5 of 21 rooms still tested positive. So we brought in the UVC machine, they brought in the UVC machine, and after UV disinfection, 0 out of 21 rooms tested positive for C. diff. So we show that UVC disinfection is an effective neutralizer of that persistent bacteria. So next we'll review how copper can be used in healthcare applications. Like UV disinfection, copper has been known to be antimicrobial for a super long time. The Egyptians were the first to mention the antimicrobial effects of copper in about 2600 BC. They've used copper vessels to sanitize drinking water. They used copper implements to treat chest wounds. Copper is registered with the EPA as a pesticide and can reduce colony-forming units by 99.9% in less than 2 hours. Here's a couple of real-world examples to show the reduction of surface pathogens that occurred when hospital changed some high-contact, high-touch surfaces to copper. So on the left, the Memorial Sloan Kettering Cancer Center in New York changed the bed rails, the food service tray, and the IV stands to copper-coated surfaces. And by doing so, it reduced the pathogens on those surfaces by 97%. So notice the high traffic touch surfaces are copper in the room on the right. HAIs were reduced by 58% in this VA medical center in South Carolina. Copper surfaces are a sort of passive way to reduce the bacterial load on high touch surfaces, but you do need to wipe them off. So you need to actually clean them. It makes it really effective in lowering HAI occurrences. I thought I'd throw in a real life non-healthcare example of a very high traffic area. This is Grand Central Station. Last time I checked, we had 750,000 people pass through Grand Central Station every single day. Grand Central opened in 1913, so some of the fixtures in that building can be over 100 years old. On the right here, we show some high touch surfaces like this pull handle and this railing are made of copper. So swabs were taken on a few touch surfaces, and you can clearly see the difference in CFU counts between copper and other non-copper surfaces. So the wood right beside the handle has so many more colony forming units per 100 square centimeters. Same thing with the wood on this railing versus the copper railing beside. The difference is huge. So here are some examples of copper touch products available on the market today for healthcare. We're starting to see various antimicrobial copper medical equipment being put into practice. So from stethoscopes to doorknobs and food trays, this is a great use of this material for high touch surfaces. Copper is a great application for dry touch surfaces, but keep in mind they still need to be cleaned. The thing is it's great for plumbing as well. However, the bacteria needs to be wiped away, and there's no real mechanical way to wipe away inside of plumbing. If you leave bacteria in plumbing, it creates a layer over time called the biofilm that acts as a barrier against further effectiveness. So it actually it's almost like a little crust that builds. So moving on from UV and copper disinfection, let's review ozone technology for infection prevention. You might see a reoccurring theme here. These technologies aren't new. Ozone has been used for water treatment for centuries. So ozone is a powerful and unique disinfectant. We're talking about in applications for water in this presentation. Ozone is germicidal and rapidly destroys any waterborne viruses and bacteria with nearly unmatched speed. So like chlorine, ozone oxidizes the bacteria and protozoa upon contact. The ozone penetrates the cell wall of the microorganism and ruptures them on a structural level, and the microorganisms can't reproduce. So unlike UV disinfection, there is no reduced flow rate or extended contact time required for disinfection. Ozone works in a matter of minutes. Ozonated water is non-toxic to humans at the levels required for disinfection. And the ozone produced in the water stream reverts back to H2O, reverts back to simple water within about 20 minutes. So ozonated water has been shown to be effective against many forms of bacteria, such as Legionella, E. coli, C. diff, and more. If you're eating and you think this is bad, it's just going to get worse. So apologize to anyone with a tender stomach. So these are the most common bacteria that thrive in plumbing systems. So just so you know, we're not talking out of school. We've got the data to prove the effectiveness. Timecale studies performed by third-party labs show that electrochemical water disinfection using ozone and different oxidizers can be effective at reducing waterborne pathogens with super low contact times too, within seconds or minutes. All right, we're getting into the good stuff here. Ozone is also effective against mold and mildew forming organisms. Again, if you're having lunch, I'm sorry. These next few slides aren't going to get any better. So here's an in-field example of the problems caused by mold and mildew growth in a wet environment. This is the inside of an ice machine. Sorry, this is the inside of a hospital ice machine. This photo was taken 3 months after a deep clean. So you can see the buildup of mold, mildew, and yeast. This is where your ice is getting made. This type of buildup has been found in the ice machines in hotels, cafeterias, gas stations, and restaurants. It's really hard to get in all those cracks and crevices with cleaning products on an ice machine. So some hospital ice machines have been fitted with ozonated water to use that for disinfection. So you're looking at the inside of an ice machine months after a deep clean using ozonated water. Notice there's no signs of mold or mildew. You can get right up in those cracks and you won't be finding anything growing in there. So there are bacteria and viruses that are present in our environment. They're in our ice machines, they're in our plumbing, and in any number of bodies of water. And they don't tend to cause a lot of issues out in the wild. But the problem happens when people who are sick or immunocompromised are exposed to these pathogens. It becomes a problem. And we have a solution to help mitigate waterborne pathogens. And that's by using ozonated water for hand hygiene. So it is now possible to wash your hands with water that has disinfecting properties. Infusing water with dissolved oxidants, including ozone, can help reduce the number of bacteria that's present on hands, making hand washing a lot more effective. Those same disinfecting properties will also help eliminate the sink as a source of bacterial outbreaks, which has happened, but we'll talk about that later. So healthcare staff are well trained in the method and importance and technique of proper hand washing. But it's usually not healthcare staff that's the problem. Often it's the unclean hands of the patients themselves that cause the transmission of HAIs. A study conducted in patients of hospitals using RFID tags show that they'll wash their hands only about 70% of the time. So that's like before and after eating, before and after using the bathroom. I'm really sorry if you're eating. Of those that were shown to wash their hands, only about 30% of them use soap and are only lathering for, on average, about 10 seconds. And, if the pandemic taught us anything, it's you need to lather for 30 seconds. So when you have bacteria that's left on your hand, that bacteria will continue to grow and double in less than 20 minutes. So a university study performed hand wash studies on untrained participants, just meaning like regular people, not healthcare people. So for the large percentage of people that only use water to wash their hands, the improvement in hand washing is evident. So we had 4 groups of people that washed just with tap water, with soap and tap water, soap and ozonated water only. So using soap and water showed a removal of just over 61% of the bacteria. By using the same methods with ozonated water, over 80% of the bacteria was removed. Now, you look at this chart and we're not recommending to not use soap. It's just that this study shows that behaviorally, if a patient is using ozonated water and chooses not to use soap, the benefits will still be there.
Sorry,
so we talked about biofilm. Okay.
Just a quick question before we move on to some of these next parts. We had a couple of questions coming in, kind of comparing the hand washing for ozonated water versus the cleaning that you mentioned. Are they different systems for generation?
No, it's the same system.
But be different. Would you have a central ozonated water generation, or would you have more point of use for each piece of equipment?
Yeah, so each sink has an ozone generator built in. It's shipped with the product, and it generates ozone on demand, because ozone reverts back to its water state. So the ozone molecules that are in there are not super duper concentrated. They're concentrated enough to make a difference on the spot, but it's not enough, for, you can't have a tank of it going out to the entire floor or through the whole hospital. So it's just sort of a small contained unit.
And then for like the ice machine cleaning that you had talked about, would that be like a separate sink system, like an ozonated generation in the maintenance area, or how?
Yeah, so it's actually a small inline unit for that ice machine. So that's actually a really small unit for the ice machine, that generates ozone just to be able to run that line to the ice machine.
Perfect. And then circling all the way back, actually, I had missed it originally on the UV side. They were asking, what type of unit or how do they go use UV light to clean it? I think there's a wide variety. You can either have like built-in UV, but most commonly it's like a portable UV disinfection system. Is that correct?
That's right. Yeah, they just would wheel it in, making sure that there are no human beings in the room. And then there's, it goes off for a set amount of time. It disinfects all the surfaces that it touches, and then it'll turn off, and then the staff can go in and retrieve it.
Yeah, that's one thing
I think they've actually made them into robots too. I think I've seen robots that do it.
They would have learned that from the that was it Feinson's or whatever it was, his experiment in the 1800s. Humans are not great with UV light. Let's not blast the humans with it. So yeah, we'll avoid having the humans in the room. But yeah, the machine will also have a recommended run time, and the different manufacturers have different run times and UV wattages, but commonly they're portable, either rolled in, or like you were saying, now there's some robots they may deliver it as well. Wide variety of options out there in the market.
Yeah, I've been told that getting blasted with UV lights feels like a sunburn on your eyeballs, and it does not sound fun.
No, not something I want to experience. Just like we don't want to experience the dangers of hospital waste and traps with methods for control.
No, that's right. Oh, wow. Look at that segue. So it's been important. It's been known for hundreds of years how important hand hygiene is to prevent the spread of bacteria and disease. Thank you, Florence Nightingale. Look her up. Hospitals are designed with hand hygiene sinks placed throughout the hospital to help control outbreaks. Unfortunately, in some cases, some hand hygiene sinks have actually contributed to the HAI problem. So poorly designed hand hygiene sinks have been shown to harbor and spread bacteria. So going back to 2004, between 2004 and March 2006, a prominent hospital in Toronto experienced a deadly contagious Pseudomonas outbreak that led to the death of 17 patients, and 36 other patients developed serious illness while under the hospital's care. Another prominent hospital experienced 66 patients infected or colonized by a very pesky drug-resistant bacteria called Klebsiella oxytoca from the fall of 2006 to the spring of 2011. So these were highly publicized instances where an outbreak was traced back specifically to a sink. The problem was twofold. It wasn't just, it was the design of the sink as well as the bacteria inside of the sink that was making people sick. So the bacteria that lives in a sink drain is shaped by what we're putting down them. So that's a quote from Zoe Whitley, who's a researcher at the University of Reading. She published a study of sink drains on a university campus, but the principle applies even more so to hospital drains because, I mean, they put everything down that drain, sometimes maybe when they shouldn't. So what makes waste traps, especially hospital waste traps, super dangerous, as we know now. Waste traps are a perfect breeding ground for bacteria. It's dark, it's wet, and they're constantly being fed a nutrient-rich diet of germs, bacteria, bodily fluids, IV bags, basically all the stuff you want to wash off your hands. Waste traps are nearly impossible to keep clean, and antimicrobial resistant bacteria continue to grow day in, day out. So this is some research done by the University of Virginia in 2017, proving that bacteria can flourish and grow in the P-traps of hospital sinks. Bacteria can also climb up from the P-trap to reach the drain area. And then all it takes is a splash of water to make that airborne. The bacteria can get splashed with water and then grow wherever they land. So the P-traps have been identified as one of the root causes of outbreaks of antibiotic-resistant bacteria. And this research has also found that bacteria can climb aggressively up the pipe at an average of 2.5 centimeters or an inch a day, and then reach the drain within 7 days. And it'll also climb through the plumbing system throughout the hospital and continue to grow outwards. So it's important to be able to contain the bacteria that's in the P-trap. So yes, my GIF is running, awesome. Once the bacteria reaches the drain, all it takes is a poorly designed sink to enable this bacteria to be splashed up to 3 feet or 1 meter away onto users, onto patients, and onto nearby surfaces. And this GIF illustrates the problem perfectly. When a faucet is installed on a sink and it shoots directly down into the drain, the water will splash upwards from that area where all that biofilm is growing. So this is just a video that we took with an iPhone, and it's showing you what happens when a faucet is mounted directly above a drain. You can see that the water is shooting down into the drain, and then you see water droplets flying everywhere. And these are just some that you can see. The water that's hitting the drain can propel bacteria from inside back onto the person washing their hands and onto surrounding surfaces. And I mean, when you think about the reason that person is washing their hands to be able to treat a patient, or a patient is going to go and eat, the last thing they're expecting is to have gross biofilm splashing back onto their hands. And that can be what happens if you have a drain that is directly under the faucet. So another means to reduce splashing from a hand hygiene sink is to incorporate geometry that will limit splashing from surface interaction with the water stream. So shown here is a splash break feature, and the principle is very similar to a ski jump landing. The impact velocity of the water is distributed out over time rather than an instantaneous hit with a flat or very slightly angled surface. No splashes on this GIF. So this is a demonstration of this in practice, of the design in practice. So these videos show how typical healthcare sinks with flat bottom surfaces and poorly placed drains can splash water and bacteria everywhere. So first, we added luminescent powder all around the waste, and we turned the light on and we washed our hands. We turned the light back off and we got our UV light out. And now you can see the flecks of the material that have been splashed everywhere. They're on the floor, they're all over the sink, they're on the back wall, they were on the person that washed their hands as well. The splashing, even though you might not feel it, it's definitely happening. So yeah, that was just a before and after of hand washing in just your typical regular sink. So this test was duplicated with a sink with a splash break feature and an offset waste. So you see where the water is going to come out is not directly where the drain is. So we poured the luminescent powder around the waste, and then the user turn on the lights, perform hand hygiene, and now you can see the end result is night and day. That luminescent powder is contained just to the drain. It's not on the walls, it's not on the user, it's not on the floor, it's not all over the sink. It's all contained because you don't have the water splashing directly onto it and then sending all those water droplets flying everywhere. So, I mean, there's only so much you can do to optimize a sink and faucet design for healthcare. You have to take into consideration human behavior. You got to take into account how a user can wash their hands in the most optimal way. And you can design a fixture to force the user to have their hands in the absolute best position for hand washing to help control splashing behavior. So this study here shows the difference between a sink with splash control features on the left and just a standard sink on the right. So the goal of this experiment was to show how much splashing actually happens in a real world scenario. So we set up the sinks and we put up white absorbent paper on plexiglass shields to the left and to the right of sinks. And the participants were dressed in painter coveralls and a mask. We covered their hands, or their hands were covered in a washable purple tempera paint, and they were instructed to wash their hands to completion, like to get all the stuff off their hands. The sinks weren't cleaned in between participants to simulate a real life setting. So as you can see, on the right, you can see that there's purple paint all over the rim of the sink, all over here. There's been a lot of splashing action happening on the sidewall as well, and then you can see all the splashing that happened on the floor. But on the left here, you can see where patients had paint on their hands, just minimal splashing on the inside of the bowl, and very minimal splashing on the paper that was applied. And that's because the user has to place their hands in front of this sensor for the water to turn on and come out here. And so their hands are forced to be in the optimal place for them to wash their hands. So earlier we learned about hand hygiene with electrolyzed or ozonated water. In addition to the benefits of hand washing, the actual larger benefit of using this treated water is to help keep the sink waste free of bacteria and biofilm. Hospitals will often use harsh chemicals or labor-intensive cleaning protocols like steam to help control biofilms, but these methods aren't always super effective. The use of oxidized water with ozone helps prevent biofilm from forming and spreading. And there's just a look at the sink itself from the front, and this picture here just shows the unit with the ozonation container in the canister in the back. So here's just to show how the technology works. It's depending on screen size, it looks pretty big, but it's about the size of your forearm. If you remember back into high school chemistry, you probably learned that water is comprised of 2 parts hydrogen and 1 part oxygen. So what's shown here is what happens when you oscillate a low-powered DC current through specialized electrodes. You can actually separate the hydrogen and the oxygen from the water itself. The free hydrogen and oxygen molecules react with the water chemistry, and in doing so, you create trace amounts of mixed oxidants from the water supply itself. So these mixed oxidants, many of which are reactive oxygen species, include ozone, hydrogen peroxide, and depending on the levels of chlorine content added by the municipality, you get hypochlorite. Again, no chemicals are added to the water. It's simply being reorganized to become hostile to pathogens. So this study was presented at the SHIA National Conference in April 2018. This is the Society for Healthcare Epidemiology of America. So contaminated sinks and drains are rapidly emerging as a cause of HAIs, healthcare associated infections, particularly in intensive care units where people are a lot more vulnerable. Drain contamination is particularly difficult to eradicate just because of biofilm formation. It makes things really pesky and really hard to treat. So testing was done at the Cleveland VA Hospital to study the effectiveness of ozonated water in eradicating bacteria, as well as a new concerning superbug, Candida auris. So their study demonstrated a total elimination at the strainer after 2 days of use and total elimination of the entire trap within 9 days of use. And they concluded that this technology has potential to reduce the number of sink-associated infections in hospitals. So to close out this section on hand washing with ozone and mixed oxidants, I'll address the most frequently asked questions. Yes, the water is safe to drink. For infection control reasons, hand wash basins aren't usually used as a source of drinking water. Secondly, the water is mixed to a nice warm temperature, and it's not super awesome to drink warm water. I'm not into it. The process does change the water chemistry, but it's well within levels allowed for potable water systems. No, the water produced by the sink won't corrode pipes. The levels of ozone produced in hand washing applications are extremely small. It's about 10 parts per billion. And at temperatures used for hand washing, they have a half-life of only about a couple minutes. So does water temperature matter? We get asked that a lot. Yes. If you're only interested in producing ozone, cold water is much more effective, as we showed in the ice machine. However, mixed oxidant production is not affected with water temperature. So you don't really want to wash your hands with cold water. It's not a comfortable experience. I've mentioned it a few times, but it's always worth mentioning again. The ozone and mixed oxidants are generated electrochemically, and depending on the electrodes used, the result is either only ozone, such as the ice machine, or ozone with mixed oxidants, which is great for hand washing. Colder water will produce more ozone with a longer half-life, and warmer water will still produce some ozone, but the other mixed oxidants produced are not as sensitive to temperature and account for the majority of the efficacy in reducing the pathogens. Ozone's not added to the water, it's created electrochemically. Ozone molecules will revert to water and the mixed oxidants will dissipate, so there's no danger of ozone off-gassing. So you don't get that, what's that smell that ozone gives? It's like, you know, after a lightning storm, you kind of get that smell with some ozone.
Well, electrochemical kind of like odor, which also
the electrochemical odor.
Yeah, not the electrochemical, but yeah, like after the lightning, you get the ozone. Which also ties, you know, the idea that it does dissipate is a design feature, which also prevents, like, you're not using this to fill up your mop bucket. This is strictly for hand washing, or like you said, the inline option for your ice machine or other types of chemicals that need to clean. Maybe they need to do all the bar lines and all those with it to kill off the bacteria. We did have a question come in actually, and first off a comment. They said thank you, and you're doing a great job in the presentation. But they ask about, you know, the IPAC leads on healthcare projects. One of the most common questions and concerns brought up from the IPAC teams is about laminar flow devices and making sure that the laminar flow device is at the base of the spout and not the outlet, because that's an opportunity for the growth of biofilm. Are we seeing a similar increase in requests for laminar flow at the base? And have you found the relocation of the laminar flow device to affect the laminar stream and splashing? So a couple of different points in there. I guess first on the regularity of laminar flow at the base of the faucet requests. Is that something that you come up, or do you want my experience there?
I mean, the unit that we're talking about with that produces the ozone does have laminar flow, and it does have a spout. We have it, this one I think is 6 liters per minute, so it's designed for healthcare. And since it has the water treatment, the ozonated water coming through it, that helps prevent the growth of biofilm, and it will actually run on a cycle if it hasn't been activated for a while. So there's really no opportunity for the biofilm to grow. Maybe I'm missing something on the question, but yeah, go ahead and if you have other things to add.
So I would say in Canada, we have seen a significant increase since Z8000 and 317 got moved along in healthcare design. Anything in a patient area or for hand wash is going to have laminar flow at the base of the spout. That's a critical component, and ensuring as well that the laminar flow of the water does not go directly into the drain. Those are universal standards, and we're seeing it included in the US as well. I know our Phil down in Florida has worked with down in California has worked with a number of engineers that are working with healthcare groups on redesigning their standards. They've given this presentation to them before as well, but in the US, it's following along as well. But in terms of mitigating splashing, those are two easy, accessible items that can get you started towards a better splash reduction and better infection prevention and control. With the ozonation, as you've seen in the presentation today, is it's a step above that. It's taking that to the next level. And relocating the drain is certainly a critical component as well. Simply changing a gooseneck with a laminar outlet to a laminar inlet on its own is not a complete program. The flow of the water directly in the drain matters, the temperature and type of water, the location and presence of the soap matters. All of that kind of comes together to form a complete anti-splash package, I would say. That's been my experience, at least. But yeah, thank you for the question. Great conversation. Anytime I can get talking on laminar flow, base versus spout, early on in a healthcare discussion is the better. The other piece I would get in that is on flow rate. That's been a common point of discussion lately with our balance between lead and healthcare quality hand wash design. And that seems to be a constant discussion that gets brought up. So the earlier you can have the conversation with your IPAC team, the owner group, the staff, your environmental team, get the answers of what your desired flow rate is and which fixtures are required to have a higher level of infection control. The earlier you have that discussion, the better. Those would be my 2 points for conversation. But yeah, thank you for the question.
Great. Yeah, I've only got a couple slides left here. So there is an urgency for action in healthcare. The annual costs of HAIs are estimated at $45 billion a year, and they account for more deaths than car accidents, breast cancer, and HIV/AIDS combined. HAIs lead to long-term disability and increased resistance of microorganisms. HAIs have worse outcomes for people who already have pre-existing conditions, and with COVID being a mass disabling event, there's a lot more people that are vulnerable to HAIs now more than ever. As we've shown, traditional cleaning methods are notoriously inefficient for decontamination in a healthcare environment, but experts feel that the adoption of these technologies, as we discussed, UV disinfection, copper touch surfaces, and ozonated water, can effectively reduce the risk of an HAI by 80% and drastically minimizing the number of HAI fatalities. So it's frequently stated that in healthcare, it takes 17 years from innovation to implementation. There's hospital overcrowding, the ongoing HAI crisis. The time for action is now. And that's that. That's what I've got.
Perfect.
I appreciate being able to discuss things throughout the presentation.
Yeah, it's funny. Everyone always has that Q&A slide at the end, but I'm a big fan of, get the question and address it as soon as we can, because it's often better to bring it up, at the point and really cover the topic that way. So we'll keep an eye on any additional questions coming in. That was fantastic, though. Angela, you did a great job. I did want to quickly show how you could find, not any of the products we talked about today, because we weren't talking about specific products because it's an AIA CEU. However, I will mention that Franke is a sponsor of the ATS spec system, which you can find by going to atsspec.com. It's all logged in. You have an individual login for you within your firm, and you can share projects within your firm, as well as a new collaboration feature that will allow you to build a project within your firm and then share it to others that are also on the system. Once you're logged in, you'll get to your dashboard like this, where you can create a quick spec. So if you're just looking for a single item with none of our rule engine applied, then you can create a quick spec. If you put in and create a new project where you add your application type, your location, the dates and everything like that, select your application type, then we can start applying a rule engine, which will identify barrier-free code based on your state, on your location. So depending on your state or your province, you may have a different standard, and we've built that in. So in BC, you would get BC building code. In California, we're making sure that all the flow rates meet the ultra-low flow standards that they may have. In Ontario, we have the OBC, et cetera, et cetera. And by putting in your bid date, we make sure that your project doesn't go out of date. So if Franke changes the model number for a particular product that's in your project, you get an update telling you, hey, this project needs some attention. It's gone out of date. We need to help you with a reselection. I've already gone in and created a quick project because I usually anticipate being short on time, but Angela did a great job. I've got a little bit more time than usual today. You can see one of the ozonated products that we were seeing throughout the presentation. But if we want to add a selection into our project file, there's a few ways we can go about doing it. We hit the plus button, takes us to our multi-category selection, where you can see everything from backflow and water heaters to pumps to basins, drinking fountains, et cetera, et cetera. You can pin your favorite as well. That's what I've done here. So if I unpin the basin, I can then search for basin. And if it's one of my repeat fixtures that I'm selecting on every one of my projects, I can pin it and it'll be at the top of my board. So you can get the most common selections that you're looking for. Once we've got into the category, we can start selecting all sorts of various products. You can filter down by basin types, or if we're looking for infection control sinks, look at your resistant. If you've got specific dimensions you need to meet, you can go through all those selections, or you can even filter by manufacturer. And we were talking about the Franke ozonated sinks today. So I'm going to bring this up. We'll see all the different stainless steel sinks and then our Mediflow hand hygiene sink. If you're looking for more details on the product, you can either search over to the filters here, or you'll see all of these tabs have a slight change where we've now integrated the manufacturer's spec sheet. So if you're looking for some specific details on the product that maybe aren't in our little calendar view here, we can look onto the spec sheet, find our exact dimensions, find the additional details. For instance, I think it does say that there's a power supply that comes with the product somewhere in the spec. A plug-in transformer, generation of mixed oxidants is included. So our power supply is included. We don't need to go through selecting any additional power supply for this product. And then if there's any options, we can configure these as well. So the MediMix is recommended so that we have the preset temperature exactly as the manufacturer designed. You can get a handheld programmer, and then you can install it with or without the shroud. And then we can add this.
Only with the shroud.
Well, they could always install it without it, but
it doesn't look great. For it to be wheelchair accessible, you need to install it with the shroud just to exactly. And it looks awesome with the shroud, I promise.
It looks nice.
It comes with, but you can get one that's a replacement.
Yeah.
If someone ever smashes it.
And then we can select our traps. And for this, we would be wanting the 1 1/4 by 1.5 inch line size. You can get it with the standard guard or without. Of course, though, we can skip anything that we don't want to select. So if we have a trap already, if we have other standards that we're using, we can just select the items that we would recommend. which is our carrier and the MetaFlow. And there's a specific carrier to go with the MetaFlow. So we've matched it up to make sure that you get the right carrier for the right product. That's part of that rule engine that I mentioned earlier. So now I'll hit complete and we can take it in. And you can see I've already labeled this one as HHS1. And I could go in and edit this and call this HHS2 or option 2, whatever you want to call it. You can change the sequencing around. And I will actually hit delete because we've already got the 1 in there. And just for ease of time, I will quickly show that we have a variety of download formats as well. We've got our PDF submittal, we've got product brochures, schedules, various written specs, the manufacturer spec package, all the Revit files, all sorts of download options. So really it's about create your project, add your selections, and it's one of the only places in the industry that you'll be able to download multiple formats specific to the product you've selected. This is not the generic manufacturer's cut sheet. This is a customized version to the selections that you've made. It comes with a nice title page that you can get your company's logo on the front, and then shows the products with the important details to get your specification. You can see this is a configured model number, not the base model number. Now we can also give you the manufacturer spec sheet package, like I mentioned. You can get all the various manufacturer spec sheets that you might need based on your selection. I wanted to show the schedule in Excel that's available as well. And these are customizable. So if you have drainage in here, if you have backflow in your you have your pumps, your water heaters, your accessories from Bobrick, then you would have different schedules similar to how you would have different schedules on your drawings. It separates them. It has specific column headers that match typical formatting. And then finally, one of the 3 versions of written specs that we provide, where you can just simply copy, paste this into your internal written format. Maybe the short format works better for you. Maybe our CSI 3-part format works better for you. Whichever one matches how your firm goes out with your written spec. Nice and easy to copy and paste in whatever it is you need to do. And you get the update accurate model number. And of course, if this goes out of date, even after you've downloaded, say they change it from the HWSS to an HW PP, I don't know, some other number. You would get a notification from our system telling you, hey, this model number's changed and updated on your current project. We recommend re-downloading, reselecting, or if it's a big change like a discontinuance, then one of my team will reach out to help you re-engage with your project.
That's awesome.
Final thing that I want to show, this is just for a single selection, but we launched a new feature recently called our ATS templates. Now you can have your internal master as well. So if you have the same selection for all your hospitals or different owner groups that one prefers manual faucets and the other prefers sensor operated faucets, you could have customized templates to those owner groups called your masters. Our ATS templates is our recommended good, better, best based on the application. So if I search up healthcare, and these are available for everyone. We have a US healthcare standard and a Canadian healthcare standard because there's different codes for those different areas. So our healthcare template for Canada is going to meet our CSA 317 all the way back through. You could go in, hit the select all, and copy all of it over into your current project or into your own master that you could then edit. Or we can just copy specific features. So let's say we need a electronic flush valve. We need a barrier-free version of that flush valve. Wait, that was the wrong one. That was our better. We're going to go with the best. And then we need a manual faucet. So the GN2FC, that's that laminar flow at the inlet that we talked about. And then we can select any electronic faucet as well. And I'll show you how you can edit this super fast as well. So if you take our standard recommendations and then we hit copy to, and we're going to find, to the project, to a master, or we can hit new. But I'm going to find the Franke one that we talked about earlier. And there's my Franke Healthcare webinar presentation I set up just as we were prepping for the call. And it's going to copy all those selections over into the project. So with a couple of clicks, I can copy from our template into a project, download, and be ready for my introduction meeting to my owner group in a matter of minutes. If you want to change this, we've already talked with the owner group and you've determined that they are interested in the ozonated faucets. We can then filter again by our manufacturers or by faucet type, search for the ozonated. The model number, you can search within the category. But we're going to see these ozonated gooseneck faucet that we can put onto this American standard basin. Again, we can include our mixing valve, we can include our programming unit, and we can hit add product. Now, we already know this comes with our power supply as well. So I'm going to delete the transformer because we don't need that anymore. And I can delete the mixing valve as well. And then hit complete. And now I've got just the components I need. And again, you can download this in any one of those formats that we talked about before. So if you're looking for the Revit files, if you're looking for the cut sheets, the written specs, anything within the system will be able to help you out. And of course, again, everything's super easy to edit and revise the title and call it whatever you need to within your firm. If you ever want a personalized walkthrough on the system in more detail, again, feel free to reach out to me, my team. We'll be happy to provide presentations for your firm or one-on-one presentations to help you figure out the ins and outs of the system. With all of that being said, thank you very much for all your time today. Really appreciate you jumping on the call with us. I ran a little bit over, I always do. I apologize. I'm always long-winded. And I'm just seeing if there's any other questions that came in. We had one person looking for budget costs. Sonia, I'll be sure to reach out to you after with the budget information, unless you have it on hand, Angela, for the MediFlow.
Not on hand, no. I shut down all my apps to make things run a lot smoother.
Understood. Yeah, I'll reach out to you after the fact. I know I owe you a project later on today anyway, so we'll be in contact. And I will be sure to bring that in the presentation or in the brochure, the package that I send you later on today. Thank you again for joining us. Thank you, Angela, for that wonderful presentation. That was very informative. Hope everyone has a great rest of the day. If you are in Canada, you'll be getting your certificate of attendance by the end of the week. If you're in the US, feel free to reach out and we can get you the number that you need to self-report the presentation today. We'll see you, I think, next week when we dive into our next topic for the ATS University. Thank you and have a great rest of the week. Bye for now.
Thanks, Zach.